Hey guys, in this session we will learn how to calculate the memory in Oracle database. So basically there are two types of processing in a database, OLTP and OLAP. Okay, OLTP means transaction processing, or you can say OLAP, analytical processing. Okay, so transaction processing means you can say banking sector. So in banking sector, daily some people transfer funds from one account to another account, and some people may withdraw money from their account, and some people deposit money in their account, right? So these are called transactions, okay, which means real-time changes. You can say insert or update or delete. These three DML transactions will be quite huge in a transaction processing system, and daily there will be huge modifications. Say for example, you are withdrawing amount from your bank account, then your balance should be reduced, right? Say for example, if you are having 10,000 rupees in your account, and you are withdrawing 5,000 rupees, and remaining 5,000 rupees should be reflected in your balance. So in that time, delete operation will happen in your from your total amount, and in your balance it will be updated as 5,000, right? So if you are adding some money to your bank account, insert operation will be happening into your existing total, right? So these kind of transactions happen in your OLTP, and based on those transactions your database need to allocate memory, right? So in OLTP system, SGA should be very high. Okay, so it is not always SGA should be high, but it depends on the database type, how the database works in real time. Okay, why? Because insert, update and delete operation need lot of IOs from the SGA, or you can say buffer cache, to disk. So in those cases, to avoid those IOs, you need huge SGA to be used, right? So in those cases, it is recommended to have a good SGA size compared to PGA. Okay, so coming to OLAP, so OLAP you can say historical processing, or archival data. So these kind of operations will be performed in sales industry. Consider that there is an e-commerce company. Okay, so that e-commerce company need to analyze the last 6 months profit. Okay, so in those cases you will be having lot of aggregate queries, which means select queries, with group by or order by, or you can say hash operations. Okay, lot of these kind of operations will be performed in your analytical systems. Okay, so that's why you need lot of PGA in order to satisfy all these operations, right? So in OLTP, insert, update or delete will happen, so that's why PGA is not required. But in OLAP, using select queries will be using lot of group by classes, so that's why high PGA will be required. Okay, some databases may be having both these types of operation. So during daytime they will enable their database for OLTP, and during night time they will enable their database for OLAP, which means like kind of batch processing. Okay, you can also say ETL, extract, transform, and load. So what they do is, the DBAs in earlier days, they used to manually adjust SGA during the daytime and PGA during the night time based on the transaction and analytical requirements. Okay, but now we have different types of memory management in Oracle, which are AMM, ASMM, and MMM. AMM means automatic memory management, and ASMM means automatic shared memory management. MMM means manual memory management. So you can just ignore this manual memory management. Why? Because until Oracle 10G, DBAs used to rely on this manual memory management, but from 10G onwards, we had automatic share memory management and automatic memory management in 11G. Okay, so we don't need to bother about manual management. So in recent versions, Oracle automatically adjusts the SGA and PGA based on the requirement. So it is kind of elastic. Okay, so automatic memory management is the most efficient kind of memory management. Okay, so let's see first of all about automatic memory management. So how you will know whether automatic memory management is enabled in your database? So you have a parameter called memory target. So this parameter, if this parameter has some value here, then automatic memory management is enabled in your database. Okay, so you have another parameter called memory max target. So this is the hard limit, or you can say this is a threshold value, and your memory target cannot exceed this value. Okay, you can say this as a soft value, and memory max target as a hard value or hard limit, you can say. Okay, so now I have the same value for both. Okay, but in real time you may have less memory target and your memory max target may be higher. Okay, so let's see how we can calculate these values. Before that, let me shut down my database. So I wanted to show you something. If I say startup, you will be able to see some messages in your screen, right? So you can see total system global area, fixed size, variable size, database buffers, redo buffers. So this is the total SGA allocation, and this is the fixed size. Okay, fixed size means there are some fixed internal tables in Oracle. Okay, you can say $X tables. So all these $X tables are fixed tables which will be there inside the data dictionary, and without these tables your database cannot perform any operations. Okay, so you have a lot of $V views, right? $V MyStat, $V database. So these $V views are based on top of the $X tables. Okay, so $X table is the source table and your views are built on top of it. Okay, so that's why you need a fixed size memory allocation to store all these tables when you start up the database. Okay, these fixed tables will not change. Okay, they will be constant and static in your data dictionary. Okay, so that's why we need fixed size. And coming to variable size, so there are a couple of pools in your SGA, right? Like shared pool, large pool, Java pool, streams pool. So all these pools are combined to form this variable size. Okay, so let's see this later. So coming to database buffer is the buffer cache which holds the data block in your SGA, and redo buffers which holds the redo log changes. Okay, which we can also call it as log buffer. Okay, so let's say show SGA. If you say show SGA, it will display all the values which are shown during the startup. Okay, so let's calculate each and every value. So I will calculate in MB. So this is the total SGA in MB. Okay, and this is the fixed size. Fixed size in MB, and this is the variable size. Or you can say shared pool, large pool, Java pool, and streams pool, like this. And this is the buffer cache. And this is the log buffer. So I am calculating these values. Okay, just compare this value with the memory target. You can say show parameter memory target. So you can see total SGA size and memory max target or memory target values same, right? So if you round it off, you will be having the same value. See, 1872 MB and here 1872 MB, right? And other components are divided, and if you add all these components, you will get total SGA. So let me add all these values. So this is the total SGA. See, you got all, the same value which you got here, right? If you add up the fixed size memory and other all the pools like large pool, shared pool, Java pool, and buffer cache and log buffer, you get the size of the SGA, right? So that is true. And so we have a couple of views which can be used also to calculate the size of the SGA. If you say select star from $SGA info, so this view contains all the information related to the memory statistics, and you can see all the fixed SGA size, redo buffers, and all these details, right? Okay, so and you also have the resident size, which means whichever memory component is using the physical memory, all these components will be marked as yes. Okay, so let's again calculate these values. If you add up all these values, shared pool size, large pool size, Java pool size, streams pool size, and your free memory. So this is the free SGA memory available. So this free SGA memory will be used for PGA. Okay. So this is called as variable size. What we are doing is we are omitting all the other pools and we are calculating the variable size. Okay. So if you divide it by this value, you got the variable size, which is 1248, correct? So if you do the same thing from the variable size which you got, you will get the same value. See, 1248, right? So this is called as variable size. You have to add up all these values and the free SGA memory available. Then you will get the variable size. Okay. If you calculate the fixed size, this is also the same value. You got 8.71 MB. So here also you can see you got 8.71 MB, right, from the startup. Fixed size. Okay. So this is how you calculate the fixed size, and we already calculated the variable size from this info. And apart from that, you can see buffer cache and log buffer. They are also the same value. You can see 608 MB. Here also you can see database buffer 608 MB. Okay. So let's anyway again calculate the buffer cache. And we can also calculate the redo log buffer. So our buffer cache size is 608 MB and our redo log buffer size is 7 MB. Okay, now if you add up all these, you will get the memory max target, which is 1871 MB, right? So you can also check in $SGA. So this is also a view which you can see, like show SGA, and we have another view called $SGA stat. So this view contains all the components inside the pools. Okay, so there are multiple different data structures in your each and every pool. Okay, you can see in shared pool itself you have a lot of data structures and linked list inside your SGA. Okay, so if you add up all these components, you will get the same value. Now we will calculate the SGA size by summing up all the components which are displayed in $SGA stat. So each and every component has size. We are adding up all these components and converting it to MB. So this is the actual SGA value. Previously we had seen memory target value and you have free SGA into it, right? This is the actual SGA MB. If you say show parameter memory target again, you have 1872. You can calculate the PGA value by subtracting memory target with the actual SGA. Now you can see 640 MB. So remaining 640 MB will be used for PGA. Okay, so both these values are part of memory target, but if you see SGA target or PGA target, both these values will be 0. Why? Because since this is a dynamic parameter, so if SGA requirement is high, SGA will get increased according to the requirement. So if you set SGA target and PGA aggregate target, that will become automatic shared memory management. Okay, so that's why these two parameters will always be 0. But if you set a value for this parameter, then that value will be acting as a minimum value either for SGA, or if you set a minimum value for PGA, that value will be set as a minimum value. So if you are setting 100 MB for this PGA aggregate target, then 100 MB will be the minimum value in automatic memory management. Okay, and maximum value will be PGA aggregate target, which is 2 GB. but now minimum value will be 0. Okay, so this is how Oracle consider the memory allocations when you set automatic memory management. Okay, so again coming to $SGA info. So here you can see, so earlier we calculated the variable size by adding up all these 4 components with the free SGA memory available. I already told you that this free SGA memory available will be used for PGA. If you again divide it by the same value, you got 640, right? Earlier also we calculated the PGA by subtracting the SGA value from memory target, right? So you got tallied with the with both the values. Okay, but consider that Oracle will not borrow any memory from SGA. Okay, so this free SGA memory available is just an indicator which shows you that this much available memory is there in the database. But PGA memory is totally separate from SGA. Okay, so PGA memory is used for processes like you can say parallel process, and they are private process, so they will not be mixed with the shared process. Shared process means SGA. Okay, so you can also confirm this in $PGA stat. So there is another view for PGA specifically. Here, if you see the aggregate PGA target parameter, so this is the actual PGA value. Okay, so again the same value, you will get 640 MB, right? And you can see maximum PGA allocated as the current value. Since this is a dynamic memory allocation, your database has used almost 402 MB up till now.